So, hello everyone, welcome to come to our talks. My name is Nelson Gomes, and shortly I will do a short presentation, just an introduction to Consul API and automated scaling. I work in Pipedrive for about 2 years, and because nowadays most tech companies use clouds, systems like Consul API and automated scaling are one of the most important. In the old days, it was common to have one HTTP server per host, one service per host. Nowadays, we can have literally dozens or hundreds of services on a single machine in different non-standard ports other than HTTP port and things like that. So the traditional way of scaling the web changed considerably. So today we have some brief introduction to service discovery. We are talking about the concepts that allow clouds to scale in number in service. How the Consul API works, how can we use it to store information that allows us to scale, and I'm going to do a short demo. Basically, I'm doing a load balancer with different microservices working together, showing that with this kind of approach we can do a lot of stuff. This is not very advanced, it's just, we are going just to touch the minimal, because in clouds we use more advanced solutions than the ones we are going to show today. So, what is service discovery? Service discovery basically is a way of letting the service to know which services we provide and keep it up to date. So when a service is created, we provide information to a service registry that allows us other services that need to communicate with it to know and be aware that there is a new instance of that service. So in a given moment we can have probably 1-2 instances of a given service, but if the load grows up, we need to deploy more instances of that service. And instead of having a sysadmin trying to deploy more instances of the same service over and over again every time it needs, basically we can click a button and start 100 instances of that services that get registered on that service discovery server, and everyone will be aware that there are new service instances ready to provide service, that specific service. So we can have services that provide static content, REST APIs, and we can basically scale and downscale according to our needs. Service discoveries works around 3 major concepts. Basically, a service provider, that's easy, a web server, a Redis server. Every service that we need is basically a service provider. We have a service consumer that needs to use the service registry to know where are the instances of the service I need to do my job as a service consumer. And putting all this together, we can basically put two ways of using that information. One that we are going to talk today is the server-side discovery. Basically, we are having a server that is updated by the service registry to getting all the instances of the APIs it needs and updates itself. So every time I deploy a new service, it gets into the service discovery, gets available on the server that works as a load balancer, and that is what our demo consists. We are in the demo phase, basically creating a load balancer with several different services that are deployed into the service registry and automatically get available through our load balancer. On the client-side discovery, basically each client fetches the information it needs. So it cannot cache the information for long periods of time because services in clouds get killed and restart very often, especially if we do continuous integration and continuous deploy. So the customer needs to have a cache and needs to pull every few seconds to know the instances available of the service it needs to work. So ideally, each service has a health check. So when we give an instance of a service to the service registry, we also provide information to the service registry to be aware if that instance is healthy, if it's working correctly or not. That's very important because here in Pipedrive, for instance, we deploy per day hundreds of times probably. So the same service gets killed and restarted and killed and restarted. So there is not a single instance of a service that probably stays on the same server for more than a few hours, probably. So when we try to shut down a service, before shutting down the service, we start to inform our health endpoint saying we are not healthy. This instance of the service is not healthy. Why is it not healthy? Because it received the signal that the container is going down. So it starts to provide information to the service registry. I'm not okay. So the service registry will provide every client that reads the information, oh, this instance of this service is not okay, don't use it. So the load balancer, the client, everyone will stop trying to use that instance of that service because it's not healthy anymore. But that's the usual, because we want to kill it and to replace it with a new instance. So, especially with HTTP, it's very important to have a health check on each service. Usually, when we have, imagine, 10 web servers, and we need to deploy a new version of that instance of the web server, we don't kill them all. If we kill them all, what will happen? Basically, the server is down. We cannot kill 10 instances at once. When we deploy, we start killing one instance at a turn, kill one, replace by a new one, kill the other, replace by a new one, and this way we can deploy an entire data center without even the user noticing. The important thing is that we replace instance by new instances without anyone noticing that a new deploy was done. That's not easy to do. That's why we need health check. Otherwise, we kill everything, a new request arrives, and there is no instance of that service to attend it. So the service is down. Usually, for this to work, we need to have at least 2 instances of any service. Why? Because we need to kill one, and we need at least one working. So when the new one comes up, I can kill the second one and replace it with a new one. So no problem with that, because all the clients were informed that that instance was getting out of the instance pool and replaced by a new one. So everything kept working as usual. That's how things get done correctly without causing the users any problems. So, what are the service discovery benefits? We have something that knows all the information of my services for my company. So if I go to service registry, I know which services are there, I know which instances of the service are available, which ones are not. If I need to scale more instances, I just create new and inform there are 100 instances of my web server, so they are always up to date and available. So sometimes in some websites and some companies, there are services like authentication that have probably less requests than another service that provides billing or some other feature. So sometimes we need to have 100 containers of a service, sometimes we need to have 10 containers of a service on different REST APIs. Because we declare our services to the service registry, we can grow and scale horizontally. So we can have either 100 instances of authentication if we need. If we have a denial of service attempt on our website, we can scale it up to avoid downtime. So this makes very easy to manage cloud infrastructures. Another thing that it's very different from the way things were done in the old times was that every HTTP server was using a port 80. Nowadays, probably the only service that is using the port 80 is a load balancer or something that faces public. Internally, we can have servers providing HTTP and on any port of the machine. So we can use all the ports of a machine instead of using just one or two or three. So that is a major help on managing infrastructure. So today, Consul is a very interesting solution. Is very widely used. We are going to talk about Consul API, not everything about Consul API, just the part that interests on today's presentation. So we are talking about registering services, storing some values, and how to use the REST APIs to do it. So one of the interesting things about Consul API is the called key value store. So if I have a dev environment, I can store my key value definitions for my service, the domain, the configurations, all the settings that are needed for the application to run, and I can do this on a tree form shape. So I can have different keys for different services, different settings, different configurations for each service, and I can get them all from a single endpoint. So if I need to update 100 instances of my service with the new setting, I don't have to kill them all. I just go there, change my setting, and hopefully, if my code doesn't cache my settings, in a few minutes, everyone will be working with that setting. So it makes a big difference to use a centralized way of storing data to all the services. How can we create a key? It's very easy. You can do it on the command line with curl, basically creating a put request to the IP address of Consul, port of the Consul. Usually the default is 8500. P1 key value. In this case, I'm creating a directory called my service with a subdirectory called domain and with a name. So I'm storing this value, and this value will become my service domain name. So every time I need to fetch the key, I can fetch it directly with curl. You can do this, or you can use any console client to do this. So Consul it has its own console client, so you can use console on a command line to store that information. So I can also delete keys and get all the keys existing on a path, but this only gives the names of the keys, doesn't give all the values. So you need to iterate over them all. We'll see that there is an easier way to fetch all keys on a subtree of console key value. That way is using transactions. Instead of fetching key by key and calling 5-10 different APIs in console, you can use console transactions to get all your keys at once, to do operations like setting information, retrieving information, creating services, removing services, and you can do up to 64 operations on a single transaction. So it saves a lot of requests to do it this way. In this example, the get tree basically will give all the keys on a specific tree of key values that I need. So if my service has all the informations there, I will receive all the settings from my service that I need to use on my service. Another very important thing is to get the services that are available on my registry. So basically, using this, I will become aware that there is a service named microservice 1 with ID microservice 1 that provides the service hello service. The hello service basically is the name of my service. So I can have probably 10, 20 different instances of hello service on console. Another important thing is the information, like the meta, and in this case, for this example, I marked all the services with the tag public route. All my services on this demo that are marked with the public route, you will see that are deployed automatically. How is that done? We will see that, but basically we can filter all the services by tag. So if I fetch all the services that match public route, probably I can do something with it. And in this case, I'm going to fetch all the services that are declared as public route. I'm going to key value store, find the public route for that service, the private route, and automatically configure the load balancer to, every time it receives some requests on a given path, to redirect to my service on the internal path that I declare. So this way we can basically create a PUT request that declares a new service. So if I start a container, I can say that I have some ID for my container, some service that I provide, give it some tags, give it the address and the port number, and voila, the service is created on console and it's available for any other client that needs this service to connect to this IP address, to this port, and do his job. So it's very easy, right? To do the opposite, basically we need to have the service ID that we declared and use it to destroy that service. After this is done, my service is no longer available, but it's only the instance that I'm going to take out of the console. If I have 100 instances, basically I have still 99, no problem. Sometimes it's important to have more information that you can find available on the Consul UI. You will see Consul UI. It's basically a web page where you can have all the information available, and you can change values, see what services are, the health check of those services, and so on. But for instance, if I need to read the times of a service, I need more information. So I can obtain a service detail calling by service ID this GET request on the console. So let's make things work, and hopefully you will see some neat stuff. So let's make things work. First of all, I created some scripts to start a few things. First of all, console. I will show you the code for it. It's very simple. So in my console, I'm just starting a Docker with a single line. With a single line, I'm starting a console server. So if I go to my console server, I will see basically this. This is my console console. So I have services, I have nodes, I have key values, and so on. But basically, I started console now, so it's completely empty. It doesn't have anything. So now I'm going to start my load balancer. Okay, I have one. This is my load balancer. It's also a Docker container. And basically, this will provide me with a server. So now I have a server running on my machine on port 80. So this is the first step. So I have console working, and I have my load balancer working. But now I will do some more interesting stuff. So the next step is to use console template. Console template is basically a console client that is connected to console and gets all the feeds about the information that gets changed. So every time a new server gets in the console, gets out of the console, some key is changed. All that information is filtered by console templates, and it updates what templates. And console template basically is a command that has a configuration. And on this configuration, I have declared two templates. One to declare the locations of my services, and the other to declare the IP addresses and ports of my services. So with this, I can very easily start my first demo. So this demo basically created and assigned a new instance of the service on my local network that provides basically a static content server to serve images, to serve CSS files, to serve any static content that we need. And because of the console templates, and if you look into this console template, this one basically is just a Nginx configuration file that tries to find all the services that have the public route tag, tries to see if any of that services have at least one instance available of that service. If none is available, the service is dead, so this makes sense to publish it. Then we found the public route of the service and check if it exists. We find the route path of that service, and if everything is okay, basically we are creating a new route from Nginx to the service. Basically, it's simple, right? So after that, I have another configuration that does exactly the same, but only updates the IP addresses of the service and the ports of the service. So we can look to the configuration that was created. So this is empty. It should have something here for my dev environment, but it doesn't have anything right now. And here I don't have any IP addresses and ports. So it's not working very well, I believe. And I already started my first demo script. So I have a public path, routed path. I have a service in Consul. So I have my Nginx static service here. I created some key values for dev environment, services, my service, and I declared the public path for it and my routed path, basically slash. The only thing that I need to start right now is Consul template. That will go into Consul, see what services are up, and update my templates. But because my load balancer is connected to the generated templates, every time the Consul template runs, it updates the load balancer. So you will see that my Consul templating is already reloading Nginx configuration. So it should be working by now, I hope. So sorry. So if I go to my config, I already have a route that goes to Nginx static service pool. And Nginx static service pool basically only has one IP address here and one port. But it's here, and Nginx already knows about it. So in this default config, everything that goes to /static goes to another service. So that should be easy, I hope. Let me just open the page. Not this one. Okay, so now I have my localhost that is responding, and now I'm going to see if static works. Some static content. Okay, it's working. So now we have a load balancer that is routing everything that goes to static to another service, and it's responding. So we already have a scalable solution. So now let's do it again. So I have one static server. I will create a new one with static server 2. So if I run my demo again, we will see that my Nginx configuration will be updated, I hope. It goes, it's up. And my config says that this was not changed, basically. Everything that was here, everything that is here stays the same because the service is the same. I only created one service and it routes this way, and this didn't need any update. But my upstreams were changed, and you saw the IP address appearing. So now if I go to my services, I should have two instances of my Nginx static service. So it's scaling up. So let's try to do another service. So I will create another service. So my demo service, it's also in images static service. And I created a new route, and I declared here to console that it has a specific path, the public path. Please notice that the value of my path is base64 encoded, so you cannot see it, but it's correct. And if we go to key value store dev services, I have this service with /images there. So everything is coming together. So now that the keys are added, the containers are up, I should go to hopefully my browser. And if I go to /images, I have something there. So it's working. In case of any doubts, and I'm sure if you are used to work with Docker, you can enter the container, go to the so here I have my file that is served, and I'm going to replace it. So now I should have images. Everything is working properly. We created two different services. We declared them to console. The console updated Nginx. And what configuration did we do? Didn't do anything. We just declared that we had a new service with the public route. Everything is working. So every time I need to create a new service, I only have to create the containers, register them. The console template will read information and filter all the containers that have the tag, and generate a new configuration and distribute all the load with different containers. All that was done automatically. So let's go up and start another demo. So this is a different one, and this one is not static. So I already reloading Nginx, so my configuration on Nginx should be working. So now I will have static, images, and hello service. So if I go to my hello service, I'm seeing hello served from container. If I put the name of a person, hello Nelson, served from container. So I already have a container working. But is it load balancing? Let's find out. So I'm going to deploy a few more instances of my microservice. So now, if I go to console, I should have already 3 different services 3 instances of the hello service working and up. The load balancer updated itself automatically, so I didn't do anything. And let's find out if it's really load balancing, because every time we refresh the page, you will notice that the container ID is changing. So now I have 3 containers doing the same service. So I scaled horizontally without touching a config file, without having to call a sysadmin to do something. I just declared the service, put a tag on it, and it's done. It's magic. But now we can see another interesting thing about service registry. Because the way I built this demo, I configured the paths in services. Each service has its own path definitions. So if I have some problem and I need to update my path to another service internally, I can change it without everyone noticing. But I can also change my public path. So if I want to change my service and want it to respond on a different path, I don't have to restart anything manually, at least. I just go here, change my hello world, wait a few seconds for Docker Consul template to do its job and update the load balancer. And now I do a refresh, and it doesn't work. Why? I changed my hello path, so my public path is not the same anymore. So I changed it to hello world. So it started to respond on a different path. So this way, I created a simple architecture that allows me to register any number of REST APIs very easily, to update them very easily without changing absolutely nothing manually. And now my architecture for REST APIs or servers is ready to scale very easily horizontally. Some notes, let me check. I will publish this demo code for the ones that are interested in learning something new. This demo's instance, for instance, basically has a container. I managed the code to show off the IP address that was assigned on the Docker network. Here I use the Consul API to register my keys. That's the magic that it's done every time I create a new service. And here I'm just publishing my information and service name. So with this, I can have either a load balancer that updates itself to have a large number of services up to date, or I can even have other services that need to call these same APIs to fetch the IP addresses of the instances that provide the service I need. So, how much time do I have?
Well, none.
None?
But
Okay.
5 more minutes. Okay, just to wrap up.
I think I'm just wrapping up. This demo, I think, was not very complex. If anyone has any doubt, please contact me.